Hi guys, so today we're doing momentum type questions, of which this one is a different one. This is a graph type momentum question, so please pay attention. Alright, good. Now, most of us were used to being given the diagrams themselves, but then when it comes to being given a graph, we struggle a little bit because we're not used to applying what we know on a graph. And yes, it is possible to be asked in the exams to draw the momentum type, the momentum graph, but it's not compulsory. For some, it's not, but in Limpopo, they usually do it. In some questions, if I remember solving some of them, right? Good. Now let's begin with this momentum versus time graph, right? So this is Q4, right? So 4.1. So the question statement or the statement above says the momentum versus time graph of object A, originally moving horizontally east, right? Is shown below, east in this direction I mean, but then it's not important for now, the direction I mean. So it's the first question states write down the definition of momentum in words. So the definition of momentum is what? Is the product of the mass and velocity of an object. Like I always say, I do not write definitions, I will only say them or state them. So, yeah, the definition of momentum is the product of the mass and velocity of an object. Now let's move to 4.2. 4.2, it states the net force acting on object A is zero between t is equals to 10 seconds and t is equals to 20 seconds. Use the graph and relevant equations to explain why the statement is true. Okay, so now we have to understand what what is it that they want from us. They want us to prove that this statement is true, that the t at t 10 is equal, t 10 seconds and t 20 seconds, the momentum is zero, right? And you can see that this is a momentum time graph. So a momentum time graph, if we look for the gradient, what do we get? The gradient is defined by the change in y over the change in x, right? So our change in y here is the momentum over what? Over the change in time. What is this? This is what? This is F net is equals to change in p over change in time. And which is what they're talking about, the net force, right? Now, we want to prove that it is zero. How can we do that? Let's look at, at the time 10 and 20. Time 10 and 20, what is the momentum at time 10 and 20? It is 50 for both of them. So it's 50 minus 50 over what? Over 20 minus 10. Now we do know that 0 or 0 over 10 is what? It's 0. So therefore the F net is what? Is 0. This is the way we can explain it. Yeah, this is the way that you can explain it to answer this question. 0. You have to know that the gradient is what? It's the F net. Good. So F 4.3, it states calculate the magnitude of the impulse that object A experiences between t is equals to 20 seconds and t is equals to 50 seconds. So they want us to calculate the impulse. Now, what is the formula of the impulse? The formula of the impulse is F net change in t is equals to change in p. Now, this is the formula for the impulse. Now, they wanted us to calculate it at time 20 and time 50, right? Okay. So, here's how to calculate it. We know that momentum is defined as the mass times the velocity of the object. Now, in this case, we do not have the mass. Is it a problem? No. Why is it not a problem? Here's why. Because the momentum itself is what? I mean the mass. The mass is constant, right? So the mass is the same. It's constant. And we do know that the mass itself is constant. Sorry about it. The mass itself is constant, and the momentum we're given, which is this one, right? Because Some may say mvf minus v initial. No, 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 don't do that because you have the momentum already. But even if you didn't have it, you do know the mass is constant. You wouldn't consider it in your calculations, right? Good. So they want us to find from T20 and T50. So we're gonna say the change final minus initial. So the final is what? It's minus 120 minus 50. Right? This is the momentum. And your answer, they said they want what? Calculate the magnitude of the impulse. Your answer is F net change in T 170. Negative what? Negative 170 kilograms meter per second, or newtons per second, right? Yeah. Remember that impulse is defined by F net times change in T. You don't need to define the divide by the time, by the way. So yeah, please, please, please take that into note. All right. Now, oh, okay. Before I even forget, just to clarify on what I said. When I said if it was a case whereby you didn't have the mass and you were calculating, you would take the mass as constant. Yes, that case it is possible, but you would have to have the velocities, because if you take the mass to be constant, the velocity will be changing, right? So the only thing that's affecting momentum here, or like always, is velocity. So yeah, so they state at t 50 seconds, object A collides with another object B, which has a momentum of 70 kilograms meters per second east. Okay, so they gave us the impulse. Oh, it's a momentum, sorry. Then they say use the information from the graph and the relevant principle to calculate the momentum of object B after the collision. Okay, they want us to find the collision, or the momentum of object B after the collision. So we're going to use the principle of linear conservation of momentum, which states sum of momentum initial is equals to the sum of momentum after. Right? So initially, what was happening? Initially, we know that it was moving with what at t50. It was moving with the momentum of negative 120, and the other one it was moving by 70 east, right? So the reason why it's negative, it shows us that it's in the other direction, which is west. So please don't be confused when you look at this. Yeah, if you draw your vectors, you know it's moving in this direction, the object B. But object A, since it's negative, it's moving in the other direction. So our answer will be this part here. This means it's still going to be moving in the other object, in the other direction, which is west, by the way. Alright. So negative 120 plus 70 is equals to what? The momentum final. The final momentum. What is the final momentum? The final momentum, we do have it, which is what? For object A, it's 50. Object A, it's 50. But then we don't have it for the other object, which is unknown. Let's just write it like this. So we know that we're going to sub them or add them up. So negative 120 plus 70, it's negative 50. It's going to have negative 100. This means the momentum of object B, it's negative 100. Negative 100 what? Kilograms meters, right? Yeah. Negative 100, of which you should write it as 100 kilograms meters per second west, like I said. Okay. Right, before I leave, let me clarify something. At T50, this is when there was a drastic change in the momentum. It went straight to 50, right? From negative 120 to 50. That's what happened. So during this T50, this is when the collision is occurring between object A and object B. So please don't get confused or not understand what I'm saying, right? But then if you are not satisfied with how I explained it, you are more than welcome to leave a comment below. and or email me to inquire more about this so that I can help you to understand much better. Well, I'll see you guys in the next one, and I hope you enjoyed this one.